Modern gold mining requires a massive physical footprint. To extract even a fraction of usable gold, companies must excavate entire mountains of rock. The heavy machinery is only the first step. The hardest work is done chemically, relying on a century-old extraction process known as cyanidation. This map shows how deeply entrenched this chemical process is. Tracking adoption rates, cyanidation accounts for 99.5% of gold extraction in South Africa, 88.1% in the United States, and has been the dominant method in China since the 1980s. Our modern supply of one of the world's most valuable resources remains entirely tethered to a single, aging chemical methodology. The active ingredient is sodium cyanide. It is highly toxic, meaning it requires extreme, costly safety protocols and poses a severe ecological hazard if mishandled. Global regulations are catching up to this risk. With strict new legislation, like China's recent environmental protection law, governments are actively punishing operations that continue to rely on toxic extraction methods. For mining companies, the financial consequences are stacking up. Between compliance red tape, complex safety requirements, and potential environmental cleanup, the basic cost of pulling gold out of the ground is skyrocketing. The industry is caught in a trap. Operations need chemicals to extract the gold, but escalating ecological and regulatory pressures are destroying profit margins. To survive, mining companies require an alternative to cyanide that is both green and economically superior. To understand why a new solution is possible, we have to look closely at the physical makeup of the raw material itself. The core chemical bottleneck is that raw ore is never purely gold. It is packed with impurity metals, specifically iron and copper, which naturally interfere with chemical processing. In traditional cyanidation, iron and copper impurities actively react with the reagents. They act like sponges, greedily absorbing the expensive chemicals before reaching the gold. This chemical theft causes heavily inflated leaching costs, drastically slowed processing speeds, and stubbornly low final yields. Beyond its ecological risks, traditional cyanidation is highly inefficient chemistry when applied to complex, real-world ores. A technological breakthrough has emerged to target this inefficiency: the JIN CHAN metallic ore dressing agent. The core innovation hidden within this new formula is the inclusion of a highly specialized impurity metal inhibitor. This inhibitor acts as a chemical shield. It targets the iron and copper, forming a stable complex and snapping tightly around the impurities to lock them up. With the impurities trapped, the extraction reagent now has a clear, unobstructed path directly to the gold. Because this reaction isolates the metals without relying on toxic chemicals, it produces clean tailings that require no special environmental treatment or costly cleanup. Financially, this unobstructed chemical pathway increases the overall recovery rate of general gold ore by 3 to 5% compared to outdated sodium cyanide. By solving the microscopic chemical bottleneck, JIN CHAN eliminates the ecological hazard while simultaneously cutting out the economic waste. When you apply that chemical efficiency at an industrial level, the green tech space becomes a highly profitable blue ocean for mining enterprises. The wasteful, toxic legacy of the cyanide era is being replaced by a driving philosophy of low consumption and high production. This visual tracks exactly how fast this bedded solution is spreading. JIN CHAN has already seen rapid export and adoption by gold mining plants in over 90 countries and regions. Major mining operations are actively replacing their century-old infrastructure with these sustainable alternatives, building unstoppable momentum across the industry. The industry is achieving true sustainability by engineering superior science to build a cleaner, far more efficient world.